So now let's have a look at the network and protocol architecture for LTE. When it comes to the network architecture of LTE, you will often hear the abbreviation SAE, which stands for System Architecture Evolution, and which indicates that also the overall system architecture for LTE was evolved, including the core network functionalities. The left figure on the slide shows the new network entities. The base stations, the so-called E-node Bs or ENBs, are directly connected to the core via the S1 interface. There is no radio network controller anymore as in wideband CDMA, so we have a very lean network architecture in LTE or SAE. The base stations are also interconnected with each other via the X2 interface. This is, for example, used to prepare handover situation and forward packets during handover. The right figure shows in more detail the functional split between a base station, an E-node B, and the evolved packet core network. The EPC or evolved packet core consists of different entities. The MME, which is the mobility management entity, the serving gateway, and the packet data network gateway. The base station, the E-node B, constitutes the evolved UTRAN, so it constitutes the radio access network, which also means that a lot of functionality is concentrated inside the base station. So you see the complete protocol stack for the radio protocols, physical layer, medium access control layer, MAC, radio link control layer, RLC, packet data convergence protocol layer, PDCP, and radio resource control layer, RRC, are part of the base station or are terminating in the base station. In terms of functions, this means that the base station hosts functionality for scheduling, dynamic resource allocation, measurement configuration and provision, radio admission control, connection mobility control, radio BIRA control, and intercell radio resource management. So there's really a lot of functionality concentrated inside the base station, a lot of intelligence. The mobility management entity on the evolved packet core side hosts the non-access stratum security protocols, the idle state mobility handling, and the evolved packet system EPS BIRA control. The serving gateway hosts functions for mobility anchoring, and the packet data network gateway constitutes the connection to the internet, for example, and functions for packet filtering and IP address allocation. This picture shows the protocol stack of the user plane over the air interface between the UE and the base station side. Actually, the names of the protocols you may already know from wideband CDMA. So we have physical layer, medium access control, MAC, radio link control, RLC, and packet data convergence protocol, PDCP. But the functional split is slightly different compared to wideband CDMA. The MAC is responsible for mapping between the logical and the transport channels, where the logical channels are defined between MAC and RLC, and the transport channels are defined between MAC and physical layer. MAC is also responsible for multiplexing and demultiplexing of data streams, for reporting scheduling information, and very important for the hybrid ARQ, automatic repeat request retransmission protocol, so for processing acknowledgements and negative acknowledgements received on the physical layer, and for deciding about retransmissions, for example. MAC is also doing priority handling and transport format selection, so in the base station all the scheduling is concentrated in the MAC layer. The RLC can be operated in acknowledged mode, unacknowledged mode, or transparent mode, so there's also an ARQ, automatic repeat request retransmission protocol, defined in RLC, resegmentation, segmentation, and concatenation, in sequence delivery, and so on. These are functions hosted in the radio link control. PDCP is doing header compression for IP packets, robust header compression. The ROC protocol is used there. So this is used, for example, to compress large IP packet headers and to improve the efficiency of transmission. Very importantly, there's a different functional split here compared to wideband CDMA. The security functions, ciphering and integrity protection, ciphering for user and control plane, integrity protection for the control plane, are hosted in PDCP as well. On the control plane side, the protocol stack is listed here. So again, you see the protocols between UE and base station over the air interface, as well as between UE and mobility management entity which are the non-access stratum protocols. So you also have for the control plane physical layer MAC, RLC and PTCP, and on top on the layer 3 you have the radio resource control for the control plane, which hosts significant functionality, for example broadcast of system information, initiating paging over the air interface, setting up the connections on RRC level, radio bearer control, so controlling all the radio bearer functionality over the air interface, releasing and establishing bearers, mobility functions like handover decisions, and UE measurement control, configuring measurement tasks for the UE and evaluating reports coming from the UE. On the non-access stratum level, we find the bearer management for the evolved packet system, EPS bearers, authentication procedures, mobility handling on paging origination in idle state, which is called ECM idle here. ECM stands for EPS connection management, and also security functions on NAS level.